First of all, happy birthday, Arweave. Tomorrow is the 7th anniversary of the launch of mainnet. It's been a pretty incredible ride. And yeah, I can't wait to see the next, well, personally, hopefully 70 years. That would be lucky at this point, but yeah, I'm excited for the future. So in this talk today, this is like a pretty internal crowd, I would say. Looking at the people here, many of you, if not most of you, work on things building on the PermaWeb each and every day. So it's a kind of, not quite private venue, I wouldn't say, but like these events are always, yeah, when the ecosystem gets to speak to itself, some of the, longer term trends come out, and they're always interesting discussions. So I thought that we could look back at the launch of Arweave 7 years later, and yeah, there's a lot of, characteristics or parts of that journey that I think this last year I've personally been feeling like we're kind of doing a replay of. It's weirdly on rails almost. And some learnings that I think can be applied from that first time round for AO, now that we're building a new compute layer on top of the base layer. Then also want to tell you all about HyperBEAM Milestone 3 and Beta 1, which comes out tomorrow. So yeah, let's jump into it. All right, this is how Arweave got started. Unfortunately, Arweave wasn't live, so we have to use a Wayback Machine link. But it was a truly atrocious website. It was called RChain, also, archiving blockchain. We changed the name after about 4 or 5 months because there was another project called A-Chain and another project that we used to call RChain because they were also, it was pronounced RChain. And that was how, yeah, the name Arweave came about. We basically realized, well, the core technology is a blockweave, not a blockchain, so why has it got chain in the name? We should just change it. But the first website was very, very basic. It was really, yeah, it was put together by Will and I in a few days. We had a white paper, some of you might have seen. In fact, looking at some of the faces in the room, some of you might remember as the, when it was the primary paper, which I'm very sorry for, by the way. It was not so great. Yeah, it was all very rudimentary. The vision was the same as we see it today. Make history permanent and make it so that you can rewind the internet. And somewhere else on this site, on this page, we talked about basically building a sister net to the internet where content is around permanently. Same mission. That was actually 8 years ago almost. There's another day, we call it Mountain Day, where the idea of Arweave was conceived. Happens in, I guess, 2 weeks. But that was 8 years ago. And this was our first office. This is the entirety of the office. This isn't a corner. This is, that's Will, Damon, and India. And in the corner there, you see a computer. We called it Big Pappy for reasons that are lost to history, I guess. But that was actually the first Arweave node, as far as, I mean, it's hard to pinpoint it precisely. But I'd say, personally, I see it as the first one. It was running Backer Alpha Testnet 3, which was a great name, nice and succinct. Which I think was where I first met the first member of the ecosystem that I still know. I can't see him. Phil, where are you? Hey, Phil.
Yeah.
Hey, yeah. I think you ran Backer Alpha Testnet 3, right? Yeah. Yeah, that was until right now a sort of private in-joke. And another was Ben Brandl. Who unfortunately I couldn't find a picture of this, but wrote the first news article of any form about Arweave, as far as I remember. Yeah, and so that was when we started to meet members of the community. And our first, I would say, big break came when we met Seb. Where are you, Seb? Hey, yeah, who was the COO or operating officer, I forget what they call it, at Techstars Berlin at the time. And yeah, at that time, things were, we raised, I believe it was 420, ironically, K dollars. And we were building out the first version of the network. But like the runway was extremely, extremely tight. It was really not obvious that this thing was going to happen at all. And we were facing, let's say, some headwinds. So, yeah. We first raised money around here-ish, followed by this peak, which at the time I can tell you seemed astronomical. It was like, well, it's just what you see today in the bubbles. It strangely, actually, 2017, 2018 almost felt more hysterical than the most recent ones, oddly. But by the time we needed to raise money again, we were down somewhere here, I believe it was. And this was not a good situation. But one way or another, we managed to make it work. And we launched the network on June 8th. This was actually written a week later. There's a fun story about the only time Arweave has truly been offline was the day before this. The day before this report was published, and Ivan and I were sitting in the at the office with Upvest, who were the first wallet creators. Out of interest, who had an Upvest wallet here? Phil? Only Phil? Wow. And Ivan, yeah, okay. Interesting. And long story short, the network DDoS'd itself to death by mass gossiping transactions without adding them to the blacklist. But it was down for 14 minutes, I should say. So not so bad. And it's never truly been offline ever since.
It was a hard exercise, very tired, hangover one day before.
To be clear, I don't remember being hungover. But I do remember there was something about beer, and then we were all sitting around the tables watching the first blocks come in that had user transactions. And like, oh wow, there's a block with 5 transactions. And there was talk of beer, and then suddenly all of the connections dropped. And then we stayed awake for the next, well, we had someone awake on rotation for the next 3 or 4 days straight, if I recall, which there was a team of 3 people, so this was not a trivial exercise. Anyway, beer, yes. Okay. But the market continued to drop after that, and the network was in a very, very rough state. It was really, there were many times right at the beginning that we had to step in and nudge it to keep it alive. I would say the worst moment for me personally was this commit, FC4FE5A, which I will never forget, unfortunately. That's one would be nice if it wasn't on Arweave. But basically, it installed a minimum difficulty, which the long story short, it just helped to keep consensus when things were very, very choppy. Yeah, it was a very, very rough time. It was really not obvious that the ecosystem, well, now what we know is the ecosystem, but at the time, just the network would make it. A few months later, this was the team. We've grown slightly. Yeah, and Lev there, I'm sure many of you have spoken to. And Sophie in the room? Hey, Sophie. We had more hair back then, I think. But the first success came a whole 6 months later, I would say, when we managed to capture on Arweave, the first records of history that actually mattered. They were basically documents pertaining to what was called at the time the Kerch Strait incident. There have probably been 5 Kerch Strait incidents since then, so now it's kind of hard to keep up. But what happened was a set of Russian naval officers boarded a Ukrainian boat, took the sailors hostage, and we managed to upload the first English language Russian propaganda outlet about the news, which was very interesting because it was basically pro-Ukrainian in the way that it was written, and it was deleted. We don't know quite how much later, but somewhere in the hour or so afterwards. But there's a permanent record of it on Arweave. You can still go find it today, of course. Yeah, and when things really started to turn around was the launch of the PermaWeb, I would say. This was, yeah, January 2019. The bottom of the, would you say, cycle was in, but also the pessimism about Arweave. Like in the ICO that happened about 6 months beforehand, the price of the token on secondary markets, Ivan might also know more about this than I do, was about $1.60-ish. We know that someone paid 3 times ICO price just to beat, ironically now, Ethereum gas fees. And by December, you could buy tokens for, I think it was 6 cents. So there was like extreme pessimism. But things started to turn the corner when we stabilized the technology, which I think is a recurring theme. So at this point, when we sort of really realized that, okay, if you have a permanent ledger of history, you have which is available in people's web browsers. You can store, yes, just news articles, but you can also store full web applications on top of it. And that creates, well, services in cyberspace that have fundamentally different properties. The theory goes something like this. Each year, humanity is pulled into cyberspace more. We never really discuss it like this. And I think I'm really curious about that. I don't know if at some point people will start to notice, or whether it was just before I was born, everyone was obsessed with this and now they're bored. And it's like boiling frogs. We're in the sort of bear market of the cyberspace hype cycle. But it seems very obvious to me that like Ben and I think, just met in person for the first time, but we've known each other for 7.5 years. And yeah, most of our lives happen in cyberspace now. Like the frequency at which we get together in gatherings like this is extremely, extremely small relative to the amount of DMs and chats we all have together. The world that we really care about is moving into computers, basically. And the attention that we put there, it's a strange thing to describe, but psychologically, I think it's reasonable to say, and subconsciously, I think this is what we're doing with our language, that we are in cyberspace. You saw it on X. You sent an email in Gmail. You are in the Google Meet room, because you really don't see the world around you while you're interacting with these applications. It may as well not exist. But it's really pretty amazing that absolutely none of this existed just at the birth of ARPANET. Like, you could only really argue that this type of experience that we're all so accustomed to and consumes so much of our attention now, it came about, was invented, like 60 years ago, a single human lifetime? And that's at maximum. It wasn't until really the 90s, late 90s even, that this shared joint digital realm that we exist in together came into existence. And now it consumes around 50% of our attention. And I think one of the most interesting things about this is that in countries that are less economically developed, the proportion of time spent in cyberspace is higher, not lower. It's not that it correlates with wealth. Actually, it's the middle band where it's the highest. South Africa, I believe, is the country with the highest screen time rate, you could say, and it's approximately 60%. Yeah, so it's a new world in which basically the same rules don't have to apply. The physics is different, if you will, right? Like, I know if I drop this, it's going to fall on the floor. And if we wanted to stop it falling on the floor, we would have to exert energy. It would be there is some cost to this. But the physics of cyberspace are just fundamentally different. They are not determined by scarcity of access to physical resources. So the example I always give, I'm sure many of you have heard me say it before, but I think it's a very clear one, is, well, Mark Andreessen and Elon Musk do not stay in the same hotel that you and I do. But they do have the same Spotify subscription. And they do use Google ChatGPT now, I guess. But they do use the same services in cyberspace. And the reason for that is because the physics of this world is different. In cyberspace, to scale experiences, all you have to do is move electrons. That is not the same as if you want to change the nature of the physical realm. And so, personally, I think that this is the most important thing that is happening to humanity, and far more important than getting to Mars or some I was about to say barren desert. It's not even a desert. It's like you better nuke it to make it better for humans to live there. This is probably not a good starting point. Yeah, managing the migration to cyberspace and making sure that when we get there and we spend more and more of our time there, it's a good world to live in is probably the most important thing we can be doing. Maybe I'm preaching to the choir, but yeah, it seems very clear to me, but I'm surprised that the whole world doesn't spend all their time talking about this. So, 50% of net attention is in this world, and it's definitely not slowing down. In fact, if you look, just say you're an alien looking at Earth. If you were to just describe what you see happening, I think it would look pretty clearly like, okay, the humans, they didn't have these machines 60 years ago, but now they're plugging their input and output sensors, basically, and actuators closer and closer into the machines. So it started with mainframes, right? And then you had university computers. And all the way along, if you look at it, the latency between interaction with the machine and the output you get from it is decreasing, and the bandwidth of connection between the human and the machine is increasing. And so, yeah, we had mainframes, and we had university computers that were shared between 100 people, more, I guess. And then we ended up with desktop computers. It was pretty rare, and then everyone ends up with a laptop, and then everyone ends up with a smartphone. And all of this is just making it so that you can interact with the machine in a tighter loop, in an easier way, transmitting information from your brain to it faster. Obviously, well, we're kind of down on the hype cycle of this as well. Down on the hype cycle is probably like, phrase of the day. Okay. All right. Yeah, the next step is pretty obvious. Who here has used VR out of interest? Kind of 50%-ish. Yeah. Well, when you put one of these things on, the modern ones, you forget very quickly that you're in a physical world at all. Like your brain will just intuit that the world that exists is the one that you're getting sense information data from. You move your head around, it looks like a 3D space, you just assume it is in some very hard to describe, I guess, way real. It is just as real to you as the physical world. And you can move your arms and legs around, it's pretty lo-fi, but does work. Where it goes next is also pretty clear. Well, you just plug in. It's pretty obviously gonna happen. You can already do it to a very minor extent. This is, each of these, I believe, transmits something like 40 bits of bandwidth per second of reading the state of neurons. But there's no physical limit that stops you doing this. So I think by the time Arweave is 50 or 70, this will almost certainly be commonplace. And then, well, the question is, what kind of cyberspace do you want to live in? And all of this happens on this scale of time that is really it's like a microsecond, or a blink of an eye, I guess they say, in the scale of human history. It's nothing. It's almost like this is happening instantaneously. And so, yeah, I think this is so clearly something that is worth people's attention. But right now, down on the hype cycle. Okay, so that's the theory. How it all started was this. Who here remembers dropping your key file? Nice, Greg, yeah. About a dozen. Ayush?
I stumbled on
Aha, interesting. Okay, well, the tech was pretty rough, but over time it improved, and now the state of user interfaces is far, far, far better in the ecosystem. So if we fast forward, I think it's about a year and a half, something like that. There were some people building interesting small things on Arweave, but it was nothing like, I mean, this room would probably have encapsulated all the people that had ever built on Arweave or something by the time this blog post was written in April 2020. And by this time, the technology was starting to catch up. But because we had not really focused on technology right at the start, we were basically, we were playing catch up with ourselves for years, and it hindered growth. During the time before this blog post, I must have taken, I would guess, 500 to 1,000 BD calls. I'll check my calendar one day, but it was a lot. And out of that, only one truly meaningful connection was made. And part of the reason for that is because, well, when people liked the idea, it was kind of interesting, But when they wanted to go use it, it just wasn't quite there. And you lost the people. And so really that attention would just have been better spent getting to Arweave 2.0, which introduced arbitrarily large block size limits, or 2 to the power 256 minus 1, technically, but virtually arbitrarily large block sizes. Yeah, we should have got here sooner. We would have saved a lot of time. It was an interesting learning. And it wasn't long after that with Seb, who was then part of our team, we started the first Open Web Foundry, which led to, where's Tate? Tate and Phil, I guess, was part of this. Phil again. Yeah, a few people in this room. It was basically starting a startup accelerator. It was pretty rough and ready, but we tried to give people all of the help that we could to get started on the network. Cyberspace is fighting back. Oh, okay. Oh, no, we're back. Brief downtime. Okay. Yeah, and so at this point, the ecosystem, as we now understand it, really started to grow. But again, this is June 2020 by this time. Like Arweave was already 3 years old. And the first real, I'd say, breakout moment that we had was, ironically, this guy, which is a llama, obviously, but it was part of some NFT collection. And Metaplex, that one BD call that we got this useful outcome from, which is very interesting for what it's worth for the founders in the room. That one was unlike all the others in that basically it went like this. We got on the phone, I explained what Arweave was. Solana core team at the time were building Metaplex, and they said, okay, cool, how do we use it? I sent them the docs. I didn't hear from them again until they were pushing like 95% of the volume of data to the network. So I don't know quite what that tells us, but I thought it was interesting. Anyway, this guy, yeah, was representative, I would say, of the first NFT craze, the mania when people started to use Arweave for something in practice. And I always find it kind of ironic that, set out to build decentralized library of Alexandria. First use case is storing monkey pictures, stoned monkey pictures, no less. C'est la vie, I guess. And for a while, actually, that kind of bugged me. But then I realized at some point, wait, well, okay, I mean, the obvious thing, which is like, good, people are using the network. That means the network survives longer. Longer the network survives, increases its probability of surviving in the future, just by the nature of the machine that it is. But also, actually, now Arweave contains, there's this particular district in Amsterdam where they used to go to trade tulips. And there's now a museum. Well, Arweave has the digital tulip museum perfectly preserved for future generations, whatever they decide to make of that. Yeah, this was a breakout moment. Again, it only happened after the technology was in the right place. And then, of course, the first, well, of course, to me, I guess probably not to. Out of interest, who here has heard of SmartWeave? Okay, more like 75%. Interesting. Yeah, this was the first version of computation on Arweave. The model was the same sort of idea as AO, but with no inter-process communication. This was 2020. And I guess this was our first brush with a different type of effect. So Arweave was a slow takeoff. It was very difficult to get people to pay attention at all. But SmartWeave and then AO was like fast takeoff, which has an entirely different set of problems. The problem with SmartWeave was, basically it was a 150-line JavaScript file that I wrote in an afternoon with a couple of engineers helping test it. It was really, really, really basic. And this was just the blog post we put out about it. Thought it was interesting. And then CoinDesk wrote about it the next day. And then suddenly there was a massive wave, I wouldn't say massive, but a decent wave of attention on it. And we were struggling to keep up with both servicing the llama kings of the world that really needed their bad pictures of animals. And by the end, it was literally random squiggles. Like, there was a day that it was very hard to upload to Arweave because none of the tooling was built to support prioritization of data uploads, which don't need priority fees in the normal way, but basically you need to bundle if you want to get around this. Yeah, there was a weekend where you could barely upload to Arweave because there were people spamming the networks with squiggles. Strange world. But we were also struggling to keep up with, the growing wave of attention around SmartWeave, which eventually became Warp and Weave VM around the same time. And that sort of, the focus moved back to just building the core infrastructure layer that was Arweave and the ecosystem around it. But then, of course, later with AO, we tried to unify that ecosystem of compute systems networks on top of Arweave in what became the actor-oriented computer. And we had our own llamas, ironically, now in retrospect, I realize. But the state of the technology in that time had increased massively. And it really seemed like as soon as we put testnet out, people were able, kind of like unlocked a wave of interest that was latent in the technology itself. It just needed to be sort of directed, which was an interesting, I guess, finding that we then lent into with the building of, I guess, the AO ecosystem, which is, I'm sure many of you here represent maybe even more so than Arweave at this point. But, LegacyNet was, well, it was a testnet when we put it out there. And so we've been playing catch up to get the technology into the right place. And so along the way, what started as just a few people, like 3 people in a tiny cupboard, basically, turned into a wide ecosystem of people all around the world building cool and exciting stuff. And that one incubator that I would say we really prototyped and then the ecosystem took forward. Community Labs has run one, and there's also Arweave India, which runs them extremely successfully, I would say. And I thought I had a picture of, that's a shame, I removed it, of Arweave Day India 2025, just a few weeks ago, a month ago, where there were hundreds of builders around creating cool applications. I think they had like 94 submissions in the sort of hackathon hour in the middle of the conference, which was pretty cool. So ecosystem has grown, but the technology needs to be in the right place to enable that. So the industry is extremely, extremely noisy. It's just the nature of working in crypto that there's massive short-term incentives that result from the availability of liquidity. I guess I'm really speaking to the founders here in the room, but also just kind of voicing what I've been thinking about for the last year. You got to focus long-term, because ultimately if you don't build sustainable things that are useful and valuable to people, you don't have a project. In that 8 years since we started building Arweave, we've seen so many things come and go that were, super cool for about 10 minutes. I remember ship chain. Yeah, it's etched into my memory forever. Ivan running into the room in this office we shared one day and shouting, "We've got exclusivity on gems."
$20 million that disappeared the moment you wired.
I'm sure they had great marketing. But that's, I guess, kind of my point, is we really need to make sure the technology is in the right place before going for growth. And that's what we've been focused on in the core team of Forward, really for the last year. But in the last 9 months or so, with the building of HyperBEAM, the new mainnet infrastructure base layer. Tech, then talk, or just build, which you'll all find in your bag. There's a nice t-shirt. Really, like, ultimately what matters in the long run is that you build something that's useful to people. Just filter the noise, and I would say do that, but that's my biased opinion. Okay, so HyperBEAM Milestone 3. This is something we've been pretty excited about. A lot of very, 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 I was about to say late nights, I guess they're late mornings technically, in the development team getting this ready. And Beta 1 comes out tomorrow on the 7th anniversary of the launch of Arweave. So just a sort of recap for the people in the room that haven't been following so closely. HyperBEAM is not really like any, well, I'm curious if anyone has any suggestions of what it's like. But as far as I'm aware, and this is not marketing speak, it truly is unlike any existing smart contracting system out there. It just doesn't, the capabilities of it and what it's focused on are not the same. It's much closer to a decentralized operating system, if you will. Well, really, the machine is AO yeah, the operating system that you use on a physical machine to sort of connect to that virtual machine is HyperBEAM. What I mean by being an operating system is that it abstracts the physical layer. So when you run Mac OS or Windows or Linux, what's really happening is that that piece of software that you refer to by those names is just making it so that the other pieces of software on top can speak to the hardware underneath that might be very varied between machines and achieve tasks. Well, HyperBEAM is exactly like that. It's an environment in which you are supposed to run other devices, we call them, other applications. And you should be able to go and download and install them on the fly. And yes, it does sort of smart contract-like things, but that's not all it does at all. And the other things, yeah, we'll get to are pretty neat, we think. So AO Core fundamentally is a primitive for trustworthy, verifiable computation. It's a way of committing, one way or another, cryptographically to the correctness of some piece of data, some output that a human can receive with some security guarantees. And those security guarantees can be swapped. It's not like Ethereum where everybody has to pay the same gas fee. So if you're doing a micropayment of, one gwei for whatever reason you'd want to transfer a trillionth of a dollar, but if you wanted to, you would pay exactly the same security fee as someone moving billions and billions of dollars. So it dissociates, it abstracts those two components and makes it so that you can swap what we call devices on either side to implement them. The system of devices is basically, I don't know what, I'm curious for feedback on this term. They're like micro-modular, well, really, from a comp sci perspective, they're state transition rules. They're ways of transforming one piece of data, an input, into an output via a request of some sort. Every single thing in the system is just modeled by message in, or message one, or the base message, and the request message that you're combining it with, and it outputs a result message, which you can then also compute further on top of. But the devices are really those state transitions. They're a way of saying, convert this input into this output. And typically they do so deterministically, although interestingly, they don't have to. In other blockchain networks, these are like entire blockchains on their own. So Ethereum has one state transition rule, fundamentally, or one set, I guess, but all applied in one monolithic group. And even things like Cosmos, Polkadot, the sort of, I'm not sure, networks of blockchains, I suppose is the right way to say it. Each of those networks is like a multi-$100 million endeavor on its own. In HyperBEAM, you can build a state transition rule in like 5 lines of Lua code. And then you can stack those on top of each other. And so the way that most of the system is constructed, if you're familiar with something like Unix, is basically having these small modules or these devices that do one thing very, very well, and then stacking them together in these sort of pipelines that transforms the state in the way that you need to. And if we do it that way, then yeah, adding to the set, innovating basically becomes extremely, extremely simple. And I'm excited to say we're going to hear from at least 2 groups that are building HyperBEAM devices of their own today. And yeah, I don't really know how many people are building these things at this point. In Arweave, India, I was very surprised when I ended up sitting on a table with people at random, and 2 people came up to me and said, oh, I built a ZK virtual machine at RISC-0 implementation as a device on HyperBEAM. And by the way, someone else is also building a CUDA device for interacting with GPUs. So there are already people doing this, even though the documentation is like, to say it's janky is, yeah, well, the laugh, I think, covers it. Already people starting to do this, which is super exciting. Hash paths, they're basically a way of referring to an individual state of computation. So every computable thing in the universe has a hash path one way or another. You can construct one that will get you to that state. And when you do so, then you can attach it with cryptographic commitments. It is signatures at the moment, but it doesn't have to be. Yeah, and then you're attaching some sort of verifiable or challengeable attestation that some computation on some set of inputs in certain sequence, in fact, it doesn't even need to be sequenced if you don't want to, leads to some output. And that's what gives you the sort of bedrock of the ability to create trustworthy computation, to be able to trust the results you see in cyberspace, and to be able to do so without trusting any individual human to be in the loop. So milestone 1, this was horrendously communicated, for which I apologize. Not very much sleep around that time. Yeah, basically the first version of HyperBEAM that we shipped was very, very targeted. The AO core resolver still hasn't changed much since then. When you see this tilde thing, it means as device. So as, in this case, relay at 1.0 or P4, which is the PermaWeb payment protocol, which used to be called P3. But then, we're debating, well, if you build a second version, is it like P32 or is it P4? So we decided to just increment the 3 in the end. But basically, it's a payment abstraction layer, if you will, and a simple payment system that allows you to just charge users for coming along and using your machine. This was in the first package, which you can construct into basically a sort of bridge into legacy net infrastructure, if you want to. So you can rate limit it and then solve one of the core problems, which is just lots of people asking for dry runs. By the way, you guys consume an insane amount of compute. You offer free compute to people. They use 12,000 CPUs, like literally 12,000 CPUs constantly 24/7, and then they still run out. Yeah, so interesting lesson there. Milestone 2, which we shipped, I think, a couple of weeks after that, enabled you to embed a Genesis WASM executor. So that's a normal legacy net sort of coup, as we used to call them. That's actually an important thing to point out. The idea of units from AO legacy net and testnet have not gone anywhere. These still exist. It's just we replaced units with something much more modular, which are devices. And then each of these devices that you have, say the scheduler, is composed of or interacts with directly, I would say 5 other devices or something like that. No, I know, maybe 10. But also it will just interact with any new device that you throw at it too. So they're kind of like X units, if you will. You can still separate out, one node over here is doing the scheduling, one node over there is doing the compute, and all the caching layers in between. But you don't have to. And you can also just make it much more fine-grained, as well as SMP 1.0. So the ability to use AMD's physical hardware for security to give trustworthiness, to give weight to those hash paths that you're signing. So you get some set of inputs, you get an output signed by a node that is, basically attaches this verifiable signature, which you can trace back to the root authority, which in this case is AMD. We want to follow up with Intel soon, and then you'll be able to get an attestation from both. And so in order for the result that you've just received to be wrong, you have to, someone has to have broken both of those pieces of hardware. If you throw ARM in there as well, then you get geopolitical decentralization. The likelihood that any one state actor could even backdoor the production of those 3 sets of chips is extremely low. Okay, so milestone 3, though, which we've been working on since then, brings legacy net process compatibility and payments for compute. This is something that, well, because it's public, and I hear people stalk my GitHub, I guess we kind of soft launched it in a sense, maybe a couple of months ago, and we're working with different people in the ecosystem to test it out. Like Bottega, for example, and Dexy were very, very early testers. I think the first public or ecosystem testers of this outside of our core team, basically just for computing the state of legacy net processes. The key issue with legacy net is kind of twofold. It's lack of payments. So you just consume that compute, and we don't want to rate limit people too much. And so everyone is competing for the same shared resource. And without any payment attached, there's no spam prevention. And the other issue is that, well, it actually takes computation in order to get a state output in the first place, which really shouldn't be necessary. What's happening in the background there is you take a WebAssembly container and you duplicate it in memory. Now, if that thing is big, it's got an LLM inside, that's like 16 gigabytes of memory copy. which is nearly a second, even on fast RAM today. Yeah, it's a huge amount of work. And it's really unnecessary. So we built solutions to both of those problems into HyperBEAM Milestone 3. And so when you look at the state of an AO process inside HyperBEAM, and this works with all legacy NEC processes from approximately, I think, October. There's actually some debate about the exact cutoff time. We'll try and work it out for the docs, but it's around October last year when there was a legacy net change that is imported into the HyperBEAM side. It looks like this. So when you see this sort of message thing at the top, and then there's that other message underneath called base, and that other message inside called process, well, each of those is like an atomic unit of information, and they can come with attestations. Yeah, and basically it expresses like the web of all computation as a giant key value store. You can create what we call a hash path, this path to get to that output. Then you can sign on top of it, and that gives you what you need to have an arbitrarily scalable, verifiable compute system. But that looks really ugly. So thanks to, well, I'm the sort of outer wrapper here, thanks to Nick. Nick, where are you? Congratulations, Nick. This is super cool. And I think people will find it very helpful. Yeah. Yeah, okay. So you can render it like this. It looks a little bit like a block explorer, but these aren't blocks. They're actually individual packets in a network with attestations attached to the correctness. And on the right-hand side, we can see, where's Pete? Sitting outside because he, okay. Long story. Yeah, who built this awesome viewer that renders the whole thing as a graph. This is just a tiny, tiny subgraph, though, of the whole, you could call it a state space. Basically, everything in the HyperBEAM decentralized operating system is represented as members, or being a member of this giant graph. If you run a node for a few days, you end up with millions and millions and millions of these connections. And you can explore them. You can see, okay, I had state A, and then I put message B on top of it, and I got message C. And you can traverse this graph, basically. And even in this part, I think, it's difficult building a technology that, with Arweave, we had slow takeoff, right? We didn't realize the idea of the PermaWeb properly. Like, had some vague notion of it until, yeah, January 2019. At that point, we've been working on the whole thing for like 18 months. Fast takeoff, very different set of problems. You learn the way to describe it to people that is intuitive only over time as you can crystallize it. And so it's been pretty difficult to describe this, but where I think this goes is that individual packets in the network, like a single send of not a sort of a message in the traditional AO legacy net sense, or a packet in the, or a transaction in the sense of Ethereum or Arweave, but I mean like an individual transfer of information from one machine to another. When it relays it onto another machine, well, it adds to the hash path. And so you get these networks of blockchains that happen as a result of communication, which I think has a lot of really, really interesting downstream consequences that we don't know yet, frankly. And if you're not a developer, I would say go find the nearest developer that you know that has like really looked into this, this technology and what it does, and ask them how it works or what it is. And in all of the, for all of the developers I've spoken to so far, no one has really been able to relate back to me what, like a succinct explanation of why, the things that this enables, basically. And so it's kind of exciting because if you understand enough about the technology, you can see there's many, many possibilities, but none of them are explored yet, and we're doing it together live, real time. And so yes, you get this cool graph of all of the different interactions between all of the different nodes and basically services in the system, and this even expands out to browsers. So you can just pick up any HTTP SIG library. Yeah, you don't need addocs. You just pick up a HTTP SIG library, sign a request, send it to a HyperBEAM node, and you're part of this graph. And again, so this page that gets sent back to the user, that is actually a verifiable blockchain interaction, if you want. You can take the output that you get there. If you look in the headers, which is really what's being shown on the left-hand side here. If you look in the headers, you will see signatures that are verifiable for the contents itself. So this expands the edge of the network all the way to the end user's machine, rather than it being like you use an Ethereum or Solana RPC node, and basically implicitly you're trusting that node operator to do so correctly. Yeah, lots of interesting downstream consequences of that. So another thing that this offers to solve one of these core issues of state access is this thing called patch, which again is just a tiny state transforming device, which takes some inputs that you can leave in your outbox in an AOS legacy net process, and that can be a sort of deep object of any kind, anything that works in Lua, and if you're using a different type of execution layer on top, anything that will serialize to JSON. Yeah, and it will expose it as part of this giant graph. Then you can point any user browser directly to the information in the computation. Like every single piece of process state or compute state has an address that will get you there, that hash path to recall it. So you can really easily build things like user interfaces on top. Say you want to get Alice's tokens. How many does she own inside a ledger? Well, instead of doing that crazy duplication thing that takes many seconds sometimes, yeah, instead you just pull out that single piece of information from the state graph and you return it to the end user instantly. It's way, way, way faster, and you can even put, because it's all layered into HTTP, all of the existing web infrastructure caching layers on top just fit elegantly in place. So you can make it insanely fast, relatively simply. And this works for all legacy net processes past October, or whenever that cutoff is, retrospectively. And something you could even theoretically do, although I don't think anyone's tried it yet, is patch the process state message itself. So change the executor, change your WASM module to make it do something that you would prefer. It's kind of all mutable now because it's process state. Yes, this thing called router at 1.0. Okay, so if we allow people to execute Genesis WASM, or rather legacy net processes inside HyperBEAM nodes, that's great, but we've still got to solve the other problem. How do you make it so that people can access compute state easily and be paid for it and get back trustworthy results? Well, all of this is sort of layered into, at least half of it approximately, is in this thing called router. And so if you ask a node, hey, how do I compute this thing? It can point you to another set of nodes. And you can register it with that router, and you can add your own little state transformer. So program it however you want in Lua, or anything else that runs in HyperBEAM to return those sets of results. And basically this allows us to run a router, or say you're an application developer and you want to give fast access to your state, or you guys can run a router too, and you can tweak it to, just by writing a little Lua script, you can tweak it to run however you think is best. Then users can come along to it and it will relay, using relay, that other device, to someone that is willing to compute it for you. And you can decide what the parameters should be for whether someone should be able to join. There's also a native Lua device inside HyperBEAM now. I would say this is, okay, the Lua device itself is relatively stable, but there's this thing called Hyper AOS, which is like HyperBEAM AOS that runs directly on top of this native Lua runtime, which is, use it if you like. It's open repo, but there are dragons, beware. Yeah, basically it's a Lua runtime that solves a sort of adjacent problem to that, like that one that also requires us to replicate the state to pull a single piece of information out of it, which is serialization. So in order to get data into a computation, you have to convert it at the moment into a JSON form and put it inside and copy and paste it, essentially, memcopy it into the WASM environment. And to do this takes a lot of time, like a huge amount of time. Actually, I think the vast majority of the compute, expensive, like spinning up an AO legacy net process is consumed by that. And so instead we realized on one of those late nights, Tom and I, where is Tom? Hey, Tom, who is also, I didn't call him out, but another immense, I would say a giant of the building of this thing. But yeah, very late night with Tom, we wondered, well, what would happen if we just use this native Lua execution environment rather than serializing and deserializing everything, and where the legacy net performance per process, and to be clear, this is not like the whole network, this is just for any individual process, of which there can be an arbitrary number. In legacy nets, about like 5 to 7 approximately messages per second. This is an extremely slow run, actually. On my laptop, which is an M2, if you run it on M4, it's substantially faster. Yeah, we get like 50 process executions per second. It's crazy fast. We've clocked it at 115 with the right configuration. So that's pretty neat. But yeah, feel free to make use of it, see what you can build. Node process. So one of the things that's really interesting about this kind of like blurs the line between smart contract and operating system universe that we're describing, is that you can get verifiable computation logs and verifiable sequencing if it runs inside an environment that you trust, like a TEE, to some reasonable degree of security. You can run like processes locally. So in the same way that you have a system config, if you will, in like a normal operating system, or you can have a local process that manages a certain part of the execution stack, which you can completely customize and do whatever you like with. And yeah, in Milestone 3 Beta 1, we're releasing tomorrow, the primary use of this will be to run ledgers. And so who, if anyone, yeah, read the subledger spec? One hand, two hands. I thought this was one of the coolest things in the AO testnet launch, but yeah, basically, so you have this problem, right? You can do 7, say, messages per second per process in LegacyNet. Well, that's cool, but like, 7 is not that much. You could make multiple copies of the token, but this would get very confusing for users. And so the testnet launch came with this spec for subledgers. Basically, the idea is, well, just fork out the liquidity in your token. Take tokens from one, kind of borrow them, if you will, put them in another process that has equal security enforcement, and you end up with, yeah, the ability to have any number of processes, any number of parallel threads executing your payment network at the same time. And when we were getting to, okay, well, we want people to be able to spin up a TEE, execute LegacyNet processes, register on a router, and have end-user compute sent to them, or end-user requests, people asking for the state of DEXY or Bazaar or PermaSwap. Yeah, we want to be able to route it to people and have them be paid. Well, how are you going to pay them? We thought, well, we'll just implement this part of the spec that was left open. And when we did so, we realized something pretty exciting, I think, which is if you have mutual enforcement of the security properties, you don't need to construct these subledgers into trees. Actually, you can have like one subledger per node. And then if you have liveness guarantees on those nodes, so those nodes can't go down, those nodes are definitely inside an environment that you trust, or running a ZK VM or whatever you want it to be, yeah, then they don't need to be constructed into trees. You can actually send tokens between nodes with relatively high security properties, I would say easily enough to cover transactions in the thousands of dollars, if not much more than that, but not like moving tokens on Bitcoin level. Yeah, relatively good security properties. And you can move tokens with a single packet. You can send an end user browser transaction that says, hey, I'd like to, I know, open this video on Odyssey and I'd like to pay per packet. You can put those payment headers into, yeah, that payment information into the headers. And along with your request comes the immutable, would you say, rollback resistant, basically, proof that that transaction actually occurred, as long as you can be sure that that node is online, which you can do by basically staking the node against liveness. And so that's pretty interesting and exciting. We call them hyper tokens, hyper everything, I guess. Yeah, funny enough, I'll keep it for another day. Yeah, this is in there. You can try it out, experiment with it. I think it would be really amazing. One of the big open opportunities, like massive opportunities, is just to build a payment network on top of this, where you have like 200 millisecond from anywhere in the world finality of any payment with a single packet of transfer on the internet. I don't know of any other way you can do that. It's pretty cool. So Milestone 3 Beta 1 tomorrow. I should say, damn it, I should have said this at the start. Temper thy expectations. Fast takeoff situation. Yeah, we're really dead set on making sure the technology is right so that you guys can build amazing things on top of it. This is a major step in that road, but it is not the end state. It really is a beta. There will be problems. Please report them to us. Please try stuff out. Yeah, go wild and happy birthday, Arweave.